In today's lecture, we are going to discuss about differential equations. Differential equations. In general, what is the informal definition of a differential equation? Kindly mute your mics. Thank you very much. In general, or you can say informally speaking, what is a differential equation? An equation involving an equation which involves or that involves derivatives or derivative of a function is called a differential equation. I hope you know what is a function y is equal to f of x. If this is a function and x belongs to R, then any equation which involves the derivative of a dependent variable, you can say derivative of f or y. For example, dy by dx plus 9 maybe xy is equal to something x squared or sine x or cos x. So this equation involves a derivative of a function. So this is called a differential equation in general. A differential equation can involve more than one dependent variables. Here, derivatives of the functions. If we have two functions, for example, u is equal to u of x and v is equal to v of x, then we can write a differential equation partial u by partial x plus partial v by partial y. Okay, this is equal to some function, maybe g of xy, sine xy, or anything. So this is a kind of differential equation as well, but it involves the partial derivatives of the dependent variables u and v. So the differential equations are of different kind. There are ordinary differential equations and partial differential equations. Okay. For example, there are two major types of differential equations or categories of differential equations. Number one is ordinary differential equation. Ordinary differential equations. And the second is partial differential equations. In this course, we are going to discuss only the ordinary differential equation. We are not going to discuss partial differential equations. A differential equation which involves only ordinary derivatives. So d by dx is in fact an ordinary derivative. When do we find the ordinary derivatives? When there is only one dependent variable, or this equation involves only one function, only y, or y is equal to f of x. If an equation involves only the derivatives of single function or more than function, but it involves ordinary derivatives with respect to a single variable, then it is called ordinary differential equation. Whereas if a differential equation involves partial derivatives with respect to more than one independent variables, then it is called partial differential equation. So these are two major classes of differential equations. In general, what is the definition? An equation that involves derivatives of a function, whether it is ordinary derivative or partial derivative, it is in general, we call it differential equation. In two major categories, a differential equation of this kind, or you can have some other kind of differential equation, for example, d square, maybe f, or you can write here y by dx square plus y, maybe 3y is equal to 0. Maybe this is another differential equation which involves a second derivative, but still there is a derivative. So it is called a differential equation, and it is ordinary differential equation. Now let us discuss these two major categories by defining or by writing their proper and formal definitions. The formal definition of a differential equation is an equation containing the derivatives of, let me write it for you, an equation containing or involving, you can say, containing derivatives of one or more dependent variables or dependent functions, you can say that, of functions, more than one functions, dependent, one or more dependent variables with respect to one or more independent variables. Is called differential equation, DE. Okay, in short, I call it DE. So an equation containing derivatives of one or more dependent variables with respect to one or more independent variables. What does it mean by one or more dependent variables? If we have two functions, for example, one is maybe y is equal to f of x, and the other, you can say y1 is equal to f of x maybe, or y is equal to f of x, and h, you can say another, h is equal to g of x. Now, there are two dependent variables, two functions, y and h are dependent variables. These are dependent variables, okay? And x is what? X is independent variable. Here we have only one independent variable and two dependent variables. So a differential equation, sorry, this kind of functions can also be considered in the differential equations. Another kind of functions, you can say that you have u is equal to u of x, y, and v is equal to v of x, y. Now, we still have two dependent variables, u and v. U and v are functions. U and v are dependent variables, and x and y, now there are two independent variables in one function. Here we have one dependent variable, one independent function, another dependent variable, one independent variable. Okay, these are functions involving one dependent variable. These are two functions. They have two dependent variables, y and h, and one independent variable. Here we have two dependent variables with two independent variables. Similarly, the most simplest one is what? If we have only one function, y is equal to f of x. Here we have one dependent and one independent variable. So an equation which involves derivatives of more than one dependent variable with respect to more than one independent variable. So this is how we look at the dependent and independent variables. Now, this is the general definition of a differential equation. Now we are going to discuss ordinary definition of ordinary differential equations. Definition of ODE. We call it in general ODE. ODE stands for ordinary differential equations. So in this, this kind of differential equation, it is in fact an equation which involves, or an equation containing the derivatives of one or more dependent variables with respect to one independent variable. This is. So in this case, in case of ordinary differential equation, you look at the definition, an equation containing the derivatives of one or more dependent variables with respect to one independent variable. So in ODEs, independent variable can only be one. Dependent variables could be more than one. For example, in this way, if there is only one independent variable, we can take only the ordinary derivatives of that function. For example, if we have a function y is equal to f of x, which I gave you an example there, that one, dy by dx, maybe plus 3 sine x into y is equal to maybe e raised power x. So this is a differential equation because it involves one dependent variable and one independent variable. So this is an ODE. Okay, this is an ordinary differential equation. So it involves only one dependent and one independent variable. There could be another example in which we can have more than one dependent variables. For example, as I gave you the example, or I can take some other example as well. P is equal to P of x and Q is equal to Q of x. These are two functions, P and Q, two dependent variables, but only one independent variable. Okay. So a differential equation of this kind may be dp by dx plus 9dq by dx or d square q by dx squared plus p is equal to maybe 0, anything. So this differential equation involves two dependent variables and one independent variable. Okay. And their derivatives are obviously ordinary derivatives. When there is only one independent variable in the functions, we can only take their ordinary derivatives, not the partial derivatives. So that's why we put here a condition of one independent variable in ordinary differential equations. So these are a couple of examples of ODEs according to this definition. There are many other or several other. There could be examples. For example, let me write here something. Maybe 9d squared y by dx squared plus y times dy by dx plus 9, maybe anything, 9y is equal to sine x. Okay. So this differential equation involves only one dependent variable and one independent variable. And it involves derivatives of a function, first derivative and second derivative. It can be third derivative or any order derivative. So this is an equation which involves derivatives of one dependent variable with respect to one independent variable. Independent variable should be one in ordinary differential equations. Dependent could be one or two or more. They are still ordinary differential equations. I hope you get it. If you have any question, you can ask me. If you don't have any question, let me discuss the PDEs very briefly, and then we'll move to the basic terminology of differential equations. Now, what are the partial differential equations and what is the formal definition of partial differential equations? Partial differential equations. Okay. The formal definition of the partial differential equations is that there is not a focus. Yeah. I hope it's fine now. PDEs. What is the formal definition? An equation containing the derivatives of one or more an equation containing the derivatives of one or more dependent variables or variables with respect to more than one independent variables. Okay, what is the difference between the definition of ODE and PDE? In ODE, we have exactly one independent variable. But here in PDEs, we must have more than one independent variable. So in PDEs, we must have more than one independent variables. Okay. So then that in that case, we can only take the partial derivatives of that function. For example, if we have a function y is equal to f of, sorry, not y, z. If we have a function z is equal to x, y. Okay. Now z is dependent variable, and x and y are two independent variables. This is a kind of surface function in 3D. So it can be considered as maybe partial z over partial x plus partial maybe anything z over partial square z over partial y square plus z is equal to maybe x times sine y. So this is a differential equation which involves only one dependent variable and two independent variables. If there are two independent variables, of course, we can take the partial derivatives of the given function. So this is the first example in which we have one dependent and two independent. We can have more than one dependent variables as well. As I told you earlier, if u is a function of ux, y, and maybe z as well, but at least two. V is a function of x, y. Okay. Then a differential equation which I have written earlier, partial u over partial x, maybe square u over partial x square, plus partial square v by partial x, partial y, plus v is equal to maybe any function, maybe 0. So this is a differential equation which involves two dependent variables and two independent variables. In partial differential equation, the derivatives should be partial derivatives and the independent variables in that function should be more than one. I hope you get it. If you have any question, you can ask me about these two major classification of differential equations. One is ordinary differential equation and one is the partial differential equations. These are the basic definitions of differential equations. Let me now, but in this course, we should only. जी बेटा, yes.
Sir, u dependent है x और y पे, लेकिन आपने जो इक्वेशन लिखी है partial derivative of u with respect to x squared लिखा है, लेकिन v के लिए आपने dx और dy लिखा है, ऐसा क्यों?
Partial x, partial y. There are mixed partial derivatives as well. I hope you have studied these things. Partial derivatives पहले पढ़ा हुआ आप लोगों ने?
नहीं sir.
No, sir.
Oh. Partial derivatives are basically derivatives of a kind in which we have more than one independent variable. These are not like the derivatives of simple functions which you have studied in single variable calculus. The function involves more than one independent variable, then we have to take the derivative with respect to a single variable. For example, let me tell you, maybe if this f of x y is some function x square y plus maybe x y cube, okay? In that case, we cannot take derivative with respect to two variables, x and y. We have to take derivative with respect to one variable, either x or y, okay? If we take its derivative with respect to x, partial z, we write it partial z over partial x, okay? Let me very briefly tell you, but you don't need to understand this in much detail. Z is a function of x, y, what I had written there, x square y plus x y cube, maybe, or any other function. So partial f or partial x, or you can say partial z over partial x. What will be partial f over partial x? Partial means the derivative in one direction, okay? So we are taking, as there are two independent variables, so the derivatives, the rate of change could be calculated in two directions, in x direction either or in y direction. So what is this partial f over partial x? It is the rate of change of this function only in the x direction. If we are considering change in x direction, then y will remain constant. Okay, I hope you know that. अगर आप three dimension में हैं, if you are working in three dimension and you are trying to capture or trying to find the change with respect to x variable, then here on this line y remains constant, okay? And if you are trying to find the change with respect to y, then x would remain constant on this line, okay? So this represents what? This represents partial f over partial x. And what does this represent? This represents partial f over partial y. In this case, x would remain constant. And in this case, y would remain constant, technically. So when you take partial derivative rate of change of f with respect to, or in x direction, so the derivative while taking the derivative of this function, you have to consider y as a constant. So what will be the derivative of this thing with respect to x?
So it will be 2x dy over dx plus 1 3y square dy over dx.
2x?
Sir, shouldn't it be just
Yes, sir.
2xy?
So yes, 2xy. Y would remain same. It's a constant. You can consider as a constant multiple of x square. So the constant multiple of x square would come outside, and we take only the derivative of x square. So it will be, in fact, technically y partial by partial x of x square. And plus here y cube is constant because you are considering y as a constant. So we take partial derivative of x with respect to the x, okay? So this is how we take.
Sir, but
Yes,
isn't
yeah.
it aren't we supposed to apply the product rule for x square y? Because it's like
No,
multiplying.
what I told you, while taking the partial derivative with respect to x, in this case, what you do, while taking partial of that function with respect to x derivative, you are trying to find the rate of change of that function only in x direction. So y would remain constant at this point. Is it true?
Yes, sir.
Look at this graph. This is not actually the correct graph. In fact, we have to draw a three-dimensional space. This is your x direction, this is your y direction, this is your z direction. You are, if there is some function, some surface function, okay, some function here, 3D function, and you are trying to find it's basically rate of change only in x direction, okay, then y in that direction would remain constant. Okay.
Okay, so if it had been partial derivative of y with respect to partial derivative of x, then what I'm saying, I think it will be applied then.
No, it can't be a partial derivative of y with respect to x. We have two independent variables. the rate of change of that z, the rate of कह सकते हैं surface function की जो rate of change है, that depends on the variation of x and y, because the function is the height is z, but the base is x and y. It depends on the change of x and y. So if you are trying to know how does that function change with respect to x, then y would remain constant in that direction. So we'll consider y as a constant. Simple. I hope you get it. This in fact clears the concept in a better way. While you are going to see the change in x direction, y will remain constant here. Okay. And while you are going to see the change in y direction, x will remain constant here. Okay.
Yes, sir.
तो यहाँ पे y को constant treat करेंगे हम. तो derivative जो होगा वो क्या हो जाएगा, y as it and इसका derivative 2x plus y cube as it, x का derivative 1. So this is your, after simplifying, you get partial derivative of f with respect to x. Now, if you want to find partial f over partial y, now you are going to compute the rate of change of f in y direction. In that case, x will remain constant here. So it will be x squared is a constant. It can be written outside that thing, derivative. So this will be this plus x partial by partial y of only the y variable, because the y only changes here, x doesn't change here. So the derivative here, rest is the same. It's just the notation. We take here partial derivative of y with respect to y as we take the derivative in ordinary derivatives, the simple derivatives which you have already studied in your single variable calculus. So its derivative is what? 1 plus x as its derivative is what? 3y squared. After simplifying, you get partial f over partial y. Now, these are the first order derivatives. There are second order derivatives as well. Okay. Second order derivatives, they could be of three kind or maybe four kind. The second derivative could be partial square by partial x square, partial square f by partial y square. But in this case, after taking first derivative, you can, after finding the rate of change of f with respect to x, then in the second time you are interested to find the rate of change of this thing with respect to y. In that case, what you have to compute, it is partial by partial y of partial f over partial x. Okay, then this thing can be written as partial square f or partial y partial x. So this is basically the mixed kind of derivative respect to x and then respect to y. Similarly, we can define partial square f over partial y and then partial x. It is what? It is partial by partial x of partial f over partial y. So these are basically kind of second derivatives, partial derivatives, respect to x, respect to y, and respect to xy, both mixed.
So
So
can you
these
repeat
are
this point?
which one?
So this partial square f over partial x square.
This the thing. आपके पास you have a function f partial f over partial x, which is this one. Now you are interested to find the rate of change of this function with respect to y. पहले आपने x का derivative find किया, then after getting partial f over partial x, you are interested either in finding again its rate of change in x direction in order to compute the second derivative, or you can also compute its rate of change with respect to y.
Like, so we already have partial f over partial x. So that is something that's written within the brackets. So we already have that. So what are we going to do? Are we going to take it with respect to y again in order to find this
Yes.
square thing?
Yes. You have already partial f over partial x. Now you are interested in finding rate of change of this thing with respect to y. That is basically your second derivative. Okay. And
Right.
in short, we can write it partial, partial, partial 2, maybe, and partial y, partial x. Okay, that's the notation for second derivative in partial derivatives.
Excuse me, sir.
जी.
Sir, अगर ये होता, okay, please continue.
Yes, tell me, what is your question? No? Okay, these are just basic concepts of partial derivatives. We are not going to use this. Basically, you will study these things in your maybe vector calculus course, because अभी आपने calculus 2 या vector calculus अभी आपने नहीं लिया होगा, I hope. So then you would discuss these things in much detail. We don't need these things here. In fact, I don't want to waste much time on it. Yes, who has raised the hand? Ask me a question.
यही पूछना था कि जो पार्शियल एक्स स्क्वायर है और जो नीचे आपने साइड पे पार्शियल वाई पार्शियल एक्स लिखा है, दोनों सेम है?
No, they are different. They are different technically.
अच्छा, तो सर जो पार्शियल स्क्वायर एफ और पार्शियल एक्स स्क्वायर है, वो क्या फिर से हम विद रिस्पेक्ट टू एक्स करेंगे?
ये हाँ, this is what? This is the rate of change of f with respect to x and then with respect to x. It's a double derivative. Partial f over partial x with respect to, again, rate of change with respect to x. So this is your second derivative. Okay, but second derivative can basically we can discuss first derivative with respect to x and the second derivative with respect to y, and or vice versa. The first derivative with respect to y and the second derivative with respect to x. So
सर,
ये
तो इन दोनों में क्या फर्क है? ये जो एक पार्शियल वाई पार्शियल एक्स है और एक में पार्शियल एक्स पार्शियल वाई है।
देखिए, आप इस चीज का ये फंक्शन है ना आपके पास, पार्शियल एफ ओवर पार्शियल एक्स, ठीक है, पार्शियल एफ ओवर पार्शियल एक्स. नाउ यू आर अगेन गोइंग टू टेक इट्स डेरिवेटिव विद रिस्पेक्ट टू वाई. ओके, दैट वुड बी डिफरेंट देन ये आपके पास पार्शियल एफ ओवर पार्शियल वाई है, उसका डेरिवेटिव ले रहे हैं विद रिस्पेक्ट टू एक्स. दीज टू थिंग्स आर डिफरेंट, है या नहीं?
जी सर, डिफरेंट है.
So they are in general different. They're not same.
Oh, thank you, sir.
Okay. Now we are going to, I told you we shall only discuss ordinary differential equation in this course. We are not going to discuss partial differential equations, okay? ODEs. Now, in general, ODE is what? ODE is what we consider in this course the differential equations which have only one dependent variable and one independent variable. Okay. In this course, we consider ODEs. We consider ODEs containing or containing one dependent variable with respect to one independent variable. Okay. So in this course, we will consider only the ODEs which involves one dependent variable and one independent variable. Means a kind of differential equations which I can give you a couple of examples, maybe dy by dx plus maybe 2xy equal to 0. This is a differential equation which involves only one dependent variable, which is y, and one independent variable which is x. I hope you know in a derivative, this is dependent variable and this is your independent variable. Okay, I hope you know this. So similarly, this is your independent variable and this is your dependent variable. Remember this. Other examples may involve maybe x, d square y by dx square plus 9, maybe 9y is equal to sine x. Okay. So this is another ordinary differential equation. There might be infinite many examples. So you just have to understand the idea in this definition. Okay.
So
But
what do you
kind of
mean?
ODs.
So what do you mean when
Ji?
you say one dependent? So what do you mean when you say one dependent variable with respect to one independent variable? Are you referring to this dy over dx?
Yes. dy by dx is the derivative of y with respect to x. So y is dependent. Y is dependent in this equation. So how many dependent variables are there in this equation? Only one, which is y.
One.
And how many independent variables are there in this equation? Only one, which is
One.
x.
X.
Okay. So this kind of ODEs we are going to discuss here in this course. A differential equation may involve first order derivative, second order derivative, fourth order, maybe any order. This is the first example. This is the second example. I can give you maybe sine x d4y by dx4 plus maybe dy by dx plus y 9y is equal to maybe e raised power x. This is still a differential equation, and it is ordinary differential equation, which involves only one dependent variable, which is y, and one independent variable, which is x. This derivative, in fact, tells you about the dependent and independent variable. So if I write here, for example, dp by dt plus 9y, sorry, not y, 9tp is equal to e raised power t. So what is the dependent variable here and what is independent variable here? Anyone?
Sir, P would be dependent and T would be independent.
Yeah, this is dependent variable and t is independent variable. So in fact, this derivative tells you which one is the dependent and which one is independent variable. It doesn't matter कि कौन सा variable है, y, x है, t है, anything. You have to look at the derivative involved in that differential equation in order to know about the dependent and independent variables. I hope you get it. If you have any question, you can ask me. Now we are going to discuss where do these equations come from, first mathematically and then physically. Okay. There are two possibilities that these differential equations, we can discuss that where do these equations come from. And what is the important in these kind of differential equations for us? What is important? If we look at mathematically, how do these equations come? How can we derive these equations? We can, I can tell you, the question is, where do these equations come from? Okay. So there are two possibilities here. First is mathematically, and the second is physically. Mathematically, and by using some laws of physics. Okay. From the laws of physics. Okay. If I discuss mathematically, then assume that we have a function y is equal to maybe e raised power x squared. Okay. Take the derivative of this function. What would be the derivative of this function? Here we have y dependent variable, x independent variable. If we take its derivative, dy by dx is equal to what? Sorry. Is equal to e raised
x
power
square
x square into
square
2x. Okay. Now we can replace this e raised power x by e raised power x is what? If we look at this,
y
e raised power x is equal to y. So what
y
I
into
can write
2x.
here, 2xy. Okay. Here we still have dy by dx. Okay. Now, if I take this on the other side, dy by dx minus 2xy equal to 0. Okay. Now, forget about it. You had some function. Now, what is this? This is an equation which involves derivative of y with respect to x. Okay. This is a differential equation. Take another example. You choose y is equal to sine maybe 5x. Okay. Take its derivative, dy by dx. What do you get here? 5 cos 5x. Take the second derivative, d square y by dx square. What do you get here? Negative 25 sine 5x. Now, what is sine 5x here now? It is y. Okay. I can write here negative 25y. Okay. And from here, I can write d square y by dx square plus 25y equal to 0. So what is this? This is a differential equation because it involves the derivatives of y with respect to x. So this is a differential equation, and this is again a differential equation which because it involves derivative of a function, derivatives of a function, second derivative in fact. So this is how where a function of this kind and maybe other infinite many functions where after taking the derivatives we can arrive at some differential equation which involves independent and dependent variable and its derivatives. So this is how we can obtain differential equations. Now, what is our purpose? What do we want from these differential equations? We want, if we are given this equation, what do we want? We want to find this function which satisfies this differential equation. Okay, obviously, if we derive this differential equation from this function, then what would be if we are not given this thing? If we are not given this thing, and we are given only that differential equation, this and this one, what is our purpose? Our purpose is to find solution of this differential equation of ODE, of ODEs. And what is the solution? The solution of that differential equation is what? Is that dependent variable. Okay. This dependent variable, we need to find this dependent variable y. So we need to find this. And what is this variable? It is basically function which satisfy this differential equation. If I, by using some techniques, if I find this function which is sine 5x, if I put this function here and this equation is being satisfied, then we say that this function is the solution of this differential equation. Okay. Similarly, after solving this differential equation by using some techniques, if I can find e raised power x squared, then this function satisfies this differential equation. If we put this function here, both sides will give us a true statement. So this equation will be satisfied if we put this dependent variable here. कैसे put करेंगे? अब y को यहाँ put करेंगे means x e raised power x square का derivative ले लें यहाँ पे. How to verify that a function is satisfying the given differential equation or not? If that function satisfies the given differential equation, then we say that it is the solution of a differential equation. For example, क्या था y is equal to e raised power x square. और differential equation क्या है? dy by dx negative 2xy. Yes, negative 2xy is equal to 0. Now you insert this here in this differential equation, means the derivative of y with respect to x is derivative of y. What is y? E raised power x square. Minus 2x. What is y? E raised power x square. Okay. Now, whether this thing gives us 0, it is e raised power x square into 2x minus 2x e raised power x square. Cancel ho gaya, you get the right hand side. You get the right hand side. Means this function satisfies this differential equation. What does it mean? This function is, this implies y is equal to e raised power x squared is the solution of given ODE. Okay. So what is our purpose if we are given, what we have to do if we are given some differential equation, we have to find that function, some function which satisfy this differential equation. Okay. So here also we have to find y which satisfy this differential equation, and that y, that particular function which doesn't involve any derivative kind of thing, that will be a solution of a differential equation. I hope you get it. If you have any question, you can ask me. No questions? Now, let us discuss a couple of examples from physical laws where we can derive differential equations. Any question? If there is no question, let's move forward then. Using the second thing which we are going to discuss by laws of physics.
Please camera थोड़ा ऊपर कर सकते हैं?
Okay. Yes. ये पता नहीं क्यों खराब हो जाता है यार. Is it fine now?
Yes, sir.
Okay. So let's discuss maybe the simplest law of physics where we can, by using that law, we can derive a differential equation. Maybe Newton's law of cooling. How many of you know already what is Newton's law of cooling? There's a question in the chat window. Maybe let me see. Nothing. The Newton law of cooling tells us that the rate of change of temperature of a body changes is basically rate of change of temperature of a body is proportional to the difference between its current temperature and the ambient temperature, the temperature of the surrounding. For example, आप एक चाय का कप बनाते हैं, ताजा ताजा मतलब ओवन से या चूल्हे से उतारते हैं चाय और कप में डालते हैं. उस चाय का टेम्परेचर क्या है? इनिशियली जब आप चाय चूल्हे से उतारते हैं तो इनिशियली उसका टेम्परेचर में भी 100 डिग्री होगा, ठीक है, क्योंकि उबल रही है वो चाय. तो जब आप चाय उतारेंगे कप में डालेंगे तो वी अस्यूम दैट उसका इनिशियल टेम्परेचर जो है वो 100 डिग्री है. अब उसका जो सराउंडिंग का टेम्परेचर है, रूम टेम्परेचर, दैट इज नॉर्मली डिपेंड्स कि आजकल कितना बाहर टेम्परेचर है, मे बी 25 डिग्री होगा, ठीक है, सराउंडिंग का टेम्परेचर। अब
गर्मी बड़ी हो गई है।
चलें 30 डिग्री कर लें यार, ठीक है। आपके पास एक कप ऑफ टी है, ठीक है, अ कप ऑफ टी और कॉफी मे बी, ठीक है, बहुत सारों को कॉफी भी पसंद होगी। आपने एक कप है आपके पास चाय का, ठीक है, उसमें से धुआं निकल रहा है, ठीक है, लेकिन बहुत गंदा सा कप है, गुजारा करें। अच्छा, इसका जो इनिशियल टेम्परेचर, वी अस्यूम दैट द टेम्परेचर जो है वो टाइम के साथ चेंज हो रहा है, ठीक है। सो वी अस्यूम दैट टी ऑफ टी रिप्रेजेंट्स temperature of coffee at any time t, ठीक है। अब हमें ये पता है कि जब हमने इनिशियली कॉफी इसमें डाली तो इनिशियल टेम्परेचर मींस द टेम्परेचर एट टाइम 0 इज व्हाट 100 डिग्री। हमने कहा कि टी टेम्परेचर एट टाइम 0 इज 100 डिग्री सेल्सियस, सेंटीग्रेड, सेंटीग्रेड होता है, सेल्सियस होता है, चलें जो भी है। अच्छा, एम्बिएंट
दोनों ही होता
टेम्परेचर
है।
को हम, हाँ, एम्बिएंट टेम्परेचर को हम डिनोट कर देते हैं टीएम से। टीएम इज व्हाट, इट इज अ फिक्स्ड टेम्परेचर, वी अस्यूम दैट द रूम टेम्परेचर इज फिक्स्ड, हम इसको टीएम से डिनोट कर देते हैं। सम पीपल डिनोट इट बाय टी नॉट और एनी अदर थिंग। जो रूम टेम्परेचर है दैट इज मे बी 30 डिग्री, क्योंकि आजकल गर्मी है। सो दिस इज योर रूम टेम्परेचर or the surrounding temperature or the temperature of the environment, ठीक है। अब हमने ये देखना है, now what does Newton say about it, how does the temperature of this coffee changes, क्योंकि कॉफी का टेम्परेचर ज्यादा है, रूम का टेम्परेचर कम है, तो डेफिनेटली you know that the temperature always goes from the lower side to higher side, the higher side to lower side, ये होता है ना। सो ज्यादा टेम्परेचर हमेशा रूम टेम्परेचर की तरफ डिक्रीज करेगा। मींस अगर आप ये देखें इनिशियल टेम्परेचर उसका 100 डिग्री है चाय का, तो दिस विल गो टुवर्ड्स 30 डिग्री एंड अल्टीमेटली आफ्टर सम टाइम द रूम टेम्परेचर एंड कॉफी टेम्परेचर विल बिकम सेम, आइडेंटिकल। अब हमने ये न्यूटन्स ने क्या बताया कि ये टेम्परेचर किस रेट के हिसाब से कैसे ये चेंज होगा। यू कैन कंप्यूट दिस टेम्परेचर। आप अपनी कॉफी लेके आए, एक एक्सपेरिमेंट करें घर में बैठ के, कॉफी को चूल्हे से उतारें, कप में डालें, अस्यूम दैट कि 100 डिग्री टेम्परेचर है उसका। आप यू कैन कैलकुलेट कि कितने टाइम के बाद इसका टेम्परेचर क्या होगा, मतलब शुरू में तो नहीं पी जा सकती ना। तो अगर आपने ये देखना है कि कितने टाइम के बाद इसका टेम्परेचर अगर 60 डिग्री पे आ गया तो मैं इसको पी सकता हूं, तो वो टाइम यू कैन कैलकुलेट कि कितने टाइम के बाद मैं ये कॉफी पीने के काबिल हो जाऊंगा। Now, what does this Newton's law of cooling tell us? That the rate of change of temperature of the coffee dt by dt. So capital T is the temperature and small t is the time. Rate of change of the temperature of a coffee is proportional to its current temperature minus ambient temperature. This is what Newton proposed कि इस तरह उसका temperature change होगा, ठीक है। So the temperature of that coffee changes. It is proportional to the temperature, its current temperature minus the ambient temperature or the room temperature. Okay. अब rate of proportionality इसको proportionality को अगर हम हटाएंगे तो आपके पास क्या आएगा? You will get dt by dt is equal to some constant k times t minus tm. So this is your differential equation. So from this Newton law of cooling, we can derive a differential equation which involves basically derivative of the dependent variable. What is dependent variable here? We assume that t is the dependent variable and small t is independent variable. Now, अब हम किस चीज में interested हैं? हमने find करना है this capital T of t. This thing. We need to find this function t of t, which will tell us, which will give us a function in terms of t, which will give us a function in terms of t, and by inserting any value of t, we can find the temperature of that coffee at any time, whatever we like. Okay, so this is the idea behind where do these equations come from, mathematically as well as physically. I hope you get it. If you have any question, you can ask me. जी
अगर रूम का टेम्परेचर भी चेंज हो रहा हो, फॉर एग्जांपल कोई फैन चल रहा है या एसी चल रहा है, तो फिर पार्शियल डेरिवेटिव्स हम लेंगे?
नहीं बेटा, उसमें Tm जो है ना वो फिर फंक्शन हो जाएगा T का. It will still be a differential equation, but this is the most simplest model which I can tell you. If the room temperature is constantly changing, then it depends कि वो कैसे change हो रहा है. Then this function will change, or maybe some आपके room में AC लगा हुआ है, ठीक है? तो उससे आपका एक another factor जो है वो add हो जाएगा यहाँ पे, which changes ambient temperature. It depends on the condition. Then this differential equation will be will have some different form. It will involve some other factors as well. So
अच्छा, वो भी फिर रिस्पेक्ट टू टाइम होगा ना, तो इसलिए
definitely
फिर
respect to time होगा ना, ठीक है? तो वो एक फंक्शन होगा. That will be a known function. अगर ऐसी चल रहा है तो you can measure the rate of change of temperature due to that AC. So that will be a known function. I hope you get it. As this is your constant temperature, Tm here. अब completely अगर आप देखें, so this will be a complete model along with this initial condition as well. Okay, the complete model. This is called mathematical model. In fact, you can call it a mathematical model. Mathematical model. Mathematical model क्या है? It involves the differential equation, which is this thing, plus an initial condition. Initial condition, we can know it by closely observing the physical phenomena. Initial condition is what? T of 0 is what? It is 100 degrees. Okay. So this complete thing is a mathematical model. Why do we need these this initial condition here? I'll tell you later on when we will discuss methods of solving differential equations. But for now, you just remember that this is a mathematical model which describes, which this whole thing describes this phenomena. How does the temperature of a coffee decreases? Okay. Ultimately, after a certain time, the temperature will coincide with the room temperature according to this physical phenomena. And after that time, yes.
So according to this physical formula, it's going to be linear, right?
Yes, it will change linearly.
Using a
it will decrease linearly. Huh. Linear? नहीं, linear नहीं होगा. But this rate of change is basically proportional to this thing, but it will not be linear decrease in that temperature. Okay? It will not be linear.
Rate of change is linear.
Rate of change is linear, but the temperature is not decreasing linearly. Okay?
Yes.
Any other question? I hope you get it. Maybe another physical phenomena which can be used in order to obtain a differential equation is basically You can take a very simple physical phenomena of a rock. If you drop a rock from some altitude towards the surface of the earth, अगर आप यहाँ पे किसी पोल के ऊपर खड़े हैं या आईफिल टावर के ऊपर खड़े हैं या मीनार पाकिस्तान के ऊपर खड़े हैं, वहां से आप एक रॉक फेंकते हैं नीचे, ठीक है, देयर इज अ रॉक, ठीक है, तो इस पे कौन कौन सी फोर्सेस अप्लाई होंगी? रॉक कमिंग डाउन फ्रॉम सर्टेन एल्टीट्यूड, कौन कौन सी फोर्सेस होंगी? एनीवन? फिजिक्स नहीं पढ़ी हुई यार आपने?
ग्रेविटी,
यस, ग्रेविटी होगी, मींस इसका वेट होगा, वेट होगा और इसकी एयर रेजिस्टेंस होगी, ठीक है। एयर रेजिस्टेंस फोर्स जो है वो ऑपोजिट डायरेक्शन में होगी और जो वेट होगा वो टुवर्ड्स द सरफेस ऑफ द अर्थ फोर्स होगी, ठीक है। So how can we express this phenomena by using Newton's second law? Newton's second law of motion. Second law of motion. Okay. Now, air resistance is normally it is basically proportional to what? It's proportional to the distance traveled minus kx.
सर स्पीड से नहीं होती।
हाँ, स्पीड होती है, सॉरी, यस, ठीक है। So Newton, if we assume that there is no air resistance, there is only the weight force on that particle or body which is moving down towards the surface. तो इस केस में क्या होगा? F is equal to ma, ठीक है। अब फोर्स कौन सी अप्लाई हो रही है उस पे? वेट वाली, वेट फोर्स इज इक्वल टू ma आ जाएगा, ठीक है। What is a? Now what is this w? W is mg, n is equal to ma, ठीक है। अब g is a constant, mm can be cancelled. What do we get? A is equal to g, and what is a? A is basically d square x by dt square is equal to g. What do we obtain? We obtain a second order differential equation here. Now, what is our purpose here? We need to find this function x, which is a displacement function here. Okay. It is the displacement function. We need to find x of t. And by finding that x of t, we can compute the distance at any time t, which that rock has been traveled. Okay. So this is a simplest physical phenomena, which also gives us a differential equation. And this equation involves two derivatives. Okay. I hope you get it. If you have any question, you can ask me. Now, yes.
सर आपके पास a से d square x upon dt square कैसे आया? I haven't done physics, so it doesn't make any sense to me.
A is the acceleration, which is basically if we have a displacement function of any moving thing at any time t, then its first derivative is the velocity of that moving thing, and its second derivative is what? Its acceleration of that moving thing. Okay, that is A, and this is what? This is your V, velocity of that thing. I hope you get it. आपने फिजिक्स कभी नहीं पढ़ी तो दैट
जिन्होंने पढ़ी है उन्होंने भी नहीं, तो जिन्होंने पढ़ी उनका भी यही हाल है,
उनको भी नहीं समझ आया ये क्या लिखा है मैंने?
नहीं सर, ये समझ आ गया, वैसे ओवरऑल बता रहा हूँ।
ओवरऑल चले कोई बात, बस मुझे जो समझाना था। हाँ जी जी,
आया वो भी बता दें प्लीज।
F is equal to ma is the Newton's second law. Force is equal to mass into acceleration. मतलब आपके पास एक ट्रक है, आपको कितनी फोर्स लगानी पड़ेगी उसको ट्रक को मूव करने के लिए, ठीक है, मतलब उसको कितने एक्सेलरेशन तक लाने के लिए, मतलब इस पर्टिकुलर मूवमेंट के लिए आपको कितनी फोर्स लगानी पड़ेगी. दिस इज काइंड ऑफ दैट law, Newton's second law. Force is basically equal to the mass into acceleration of certain moving thing. ठीक है, अब ट्रक के लिए आपको ज्यादा फोर्स लगानी पड़ेगी उसको मूव करने के लिए या उसको रोकने के लिए, लेकिन अगर आपके पास एक छोटी सी कोई चीज है, मसलन ये रिमोट है, ठीक है, रिमोट आपने टेबल पे मूव करवाना है या एयर में, तो उसको मूव करवाने के लिए आपको थोड़ी फोर्स चाहिए हो. सो इट डिपेंड्स के बॉडी का जो मूव करवानी है आपने, उसका मास क्या है और कितना एक्सेलरेशन तक आपने उसको मूव करवाना है, तो उस लिहाज से फिर आपको उतनी फोर्स चाहिए होती है. So this is kind of law of motion which Newton gave back in maybe 15 something year. तो बहुत पुराना है. अगर आपने फिजिक्स नहीं पढ़ी तो आप what major are you going to take? Of course you should not come to SSE.
ACF.
हाँ चलें ठीक है. That is fine then. Okay, this is all about the introduction to differential equations. What are differential equations? What are their basic definitions? Where do these equations come from, mathematically as well as physically? And what if someone give us some differential equation, or we derive some differential equations from physical law? What we want from that differential equation? We want to solve that differential equation, and we want to find some function which satisfies that differential equation. Okay. The next, if you have any question in this thing, you can ask me. After this, let me give you some basic definitions about the differential equation, which gives us some basic terminology about the differential equation.
Camera please हिला दें.
G, yes. Okay, let me
camera.
change the camera. I hope this is fine now. No, it's not fine. This one. Okay. Some basic terminologies or some basic classification of differential equations, or some, you can say, basic terminologies, maybe. Basic terminologies. First definition which I wanted to tell you is the order of a differential equation. Order of ODE. किसी भी differential equation का order क्या होता है? How do we are talking about general ODE as well as PDE. Okay? This definition also works for PDEs as well. The order of a highest order derivative involved in that differential equation is called the order of a differential equation. Okay. So order of ODE is basically the order of highest order derivative. Highest order derivative.
सर हाईएस्ट डिग्री जो है
Involved.
क्या डिपेंडेंट वेरिएबल की
Highest डिग्री नहीं, ऑर्डर. अब फॉर एग्जांपल अगर आपके पास ये डिफरेंशियल इक्वेशन है, फॉर एग्जांपल, बल्कि ऊपर हमने लिखा नहीं हुआ था, काफी सारी डिफरेंशियल इक्वेशंस लिखी हुई थी ना, रेज कर दी. हाँ, यहाँ इस डिफरेंशियल इक्वेशन में इसका ऑर्डर क्या होगा? हाईएस्ट ऑर्डर डेरिवेटिव इसमें क्या है? एनीवन?
1.
One. So the order of this differential equation is 1. You are right. What is the order of this differential equation? The highest order derivative involved in this equation is
2.
2. So the order of this differential equation is 2. Okay. Similarly, partial differential equations में भी आप partial derivatives को order देखते हैं. जो भी highest order होगा वो उसका differential equation का order होगा. ठीक है. I hope you get it. If you have any question, you can ask me. No, no question. Okay. The next is the degree of a differential equation. Degree of ODE or any differential. Degree of a differential equation is the power of the highest derivative. Power of the highest derivative means मैं अगर यहाँ पे कह रहा हूँ d square y by dx square plus x into dy by dx whole 3 plus 2y equal to maybe sine x. This is an ODE. What is its order? Highest order derivative is 2, so its order is 2. Now, what is the degree of this differential equation? Is the power of the highest order derivative. What is the power of highest order derivative here?
3.
Highest order derivative. Power of the
1.
who is this P1? Kindly mute your mic. Kindly mute your mic. Yes, thank you. What is the power of the highest order derivative? Highest order derivative is what? It's 2. And what is its power? Its power is 1. So its degree is 1, not 3. This is the power of dy by dx. It is not the power of highest order derivative. It is the power of the highest order derivative is 1, so degree is 1 here. Okay. Now, if I write here d, maybe d cube y by dx square, sorry, cube whole power 3 plus maybe 9, 2y is equal to maybe 3. What is the degree of this differential equation? Now
3.
it's 3 because the highest order derivative is 3, and we will look at आप यहाँ पे इसको ये कर सकते हैं dy by dx whole power 10 is equal to maybe plus 3 is equal to 0. So if this is your differential equation 3y, if this is your differential equation, what is the degree of this differential equation? Now
3.
it is still 3 because we look at the power of the highest order derivative, not the highest power. We don't look at the highest power. We look at the power of the highest order derivative in that differential equation. That is called the degree of that differential. So the degree is 3 here. I hope you get it. If you have any question regarding the order and degree of a differential equation, then you can ask me. Who raised the hand? Ubaid
Sir,
Aslam Qureshi. जी बोले.
सर मैंने पूछना था हमारे सिलेबस में हाईएस्ट ऑर्डर 2 का होगा ना?
आपके सिलेबस में हाईएस्ट ऑर्डर हाँ 2 तक होगा.
ठीक है सर, थैंक यू.
I'll tell you later on. Any question? If there is any question, you can ask me. Otherwise, we are going to stop it here today, and we shall discuss some other basic terminologies in the next lecture. For example, these are basically classification of differential equation. We can classify them with respect to their order, with respect to their degree, with respect to their linearity, either they are linear or non-linear, and a couple of more basic concepts which help us to classify the differential equation. So what we have discussed today, generally there is, so we have a differential equation in general. It has 2 major classifications, ODE and PDEs. Okay, we discussed only ODEs in this course, and further ODEs can be classified by using order of ODE and then degree of ODEs. And then we can also classify them by using their linearity property, whether they are linear or non-linear. You can classify them linear, non-linear ODEs. And these are three major classifications of ODE. Okay. So this is what we have discussed today, the major classifications. If you have any question, you can ask me. Otherwise, I'm going to stop this lecture today here. No question?
When's your last class? Is it on the 18th or 23rd?
Last lecture will be